6-3 deals solely with polynomials, poly meaning many, and nomials meaning terms. So I apologize, I have a cold, so I sound funny. Monomials are either just a number, just a variable, or it can be a product of numbers and variables with whole number exponents. So you cannot have an exponent that's a fraction. You cannot have an exponent that is negative. You cannot have an exponent, you can have an exponent that's 0, 1, 2, 3, 4, and so forth. You cannot have any operation symbols. So some examples of monomials would be, for instance, if we had just a number, would be just like the number 5. Or just a letter would be just x. Or a product of numbers and variables could be negative 2x. Or with whole number exponents, it might look like 6y z to the 7th power. So it can be anything like that. What is not considered a monomial would look like this. Let's see. Negative 0.07x to the negative 2. What makes this not a monomial is not the coefficient of negative 7/10, but the fact that we have a negative exponent. So the other thing that would not be a monomial would be something that has more than one term. So you could have 3x plus 2, not a monomial. Or you could have something that has a variable in the denominator, that would not be a monomial. So for instance, 6x squared. So all of those are not considered monomials. What we're mostly interested with today is how do you find the degree of a monomial? Essentially, you're going to take the sum of the exponents of the variables, and that's it. So don't look at the coefficient, just look at the sum of the exponents of the variables. A constant always has a degree of 0, so that's why when we look at this monomial term here, this is a constant. Technically, it's to the 0 power, or its degree is to the 0 power. Mostly because it's got a variable attached to it that's the 0 power, but don't worry about that. What I want you to look at is these exponents right here. So it doesn't matter whether they're different bases or like bases, you're just going to add those together. So to find the degree of example 1, you're going to take 2 plus 4, and that gives you a degree of 6. So the monomial has what's called a degree of 6. In example 2, you don't see any variable. So technically, it's got an x to the 0 attached to it, and that's what I was referring to. The reason why constants have a degree of 0 is because technically, this is what's attached to it. Because anything to the 0 power is 1, that means that the variable that's attached to this constant must have been some sort of variable raised to the 0 power. So we say that this has a degree of 0. In example 3, you don't see an exponent on this variable y at all, but it's understood that the exponent is 1, so therefore it has a degree of 1. That's it on that page, so let's look at the next page. Now we want to look at a polynomial. So we looked at what a monomial was, and what's the difference between a monomial and a polynomial. Essentially, a polynomial is just a monomial or a sum or difference of monomials. So it has operation symbols of addition or subtraction in there. So this right here is a polynomial. Just the 4x itself, if you had just the 4x, even though it's a monomial, we would still consider that a polynomial. So a polynomial is one or more terms. Terms are always separated by addition and subtraction signs. To find the degree of a polynomial, you're going to find the degree of the term with the greatest degree. So you're going to find each term's degree separately, just like we did, and then whichever one of the two has the highest degree, that carries the degree for the entire polynomial. So for instance, the degree of the 4x, because the x has an exponent of 1 and there's only one variable, that means that the 4x has a degree of 1. The negative 18x to the 5th only has one variable with an exponent, so it has a degree of 5. Because the negative 18x to the 5th has the highest number, the degree of the entire polynomial is 5. Look at number or example 2. So the degree of this comes from, now make sure that anything that doesn't appear to have an exponent, that you put an exponent in there. So the y actually has an exponent of 1. So to find the degree of this term, we're going to take this exponent plus that exponent. So we've got 2 plus 1 giving us a degree of 3. The next term, both the x and the y, you don't see their exponents, but they have exponents of 1. So to find the degree of that term, you're going to add the 1 plus 1, which gives us a degree of 2. Then we have the constant here. You don't see any variables at all. So technically it has some variable with a degree of 0, which is why the degree of any constant is always 0. So which of the three terms has the highest degree? The first term. So the degree of the entire polynomial is 3. Let's apply that same logic to example 3. So again, I'm going to find the degree of the first term. So the degree of this term, there's only one variable, so it has a degree of 4. That's the exponent right here. The second term, 9x squared, again, still one variable, so its exponent 2 is the degree. The next term is negative x. We don't see the exponent, but it's understood to be 1. And the constant 3 doesn't have any exponent or any variables at all, so it again technically has a variable of x to the 0, which again all constants have a degree of 0. So out of those four terms, the 6x to the 4th has the highest degree, so the degree of the entire polynomial is 4. Now as we look at this last example, you can place the terms of a polynomial in certain order, either ascending order or descending order. So ascending means that you are going up. So if you think about it in terms of stairs and a landing, ascending means you're going from low to high. So ascending means you go from low to high, so that would be ascending. So if we were going to put this polynomial in ascending order, we would have started with the 3 because it has the lowest degree. So we would have said 3, the next lowest degree is this one, minus x, the next lowest degree is this one, plus 9x squared, and then the highest degree is this term, 6x to the 4th. Or we could go in descending order. So again, we have low, and we have high. But descending order means you go from high to low, and so that would be descending order. Currently, this polynomial is in descending order. It goes 4, 2, 1, 0, highest to lowest. So let's look at the next page. Standard form of a polynomial is where one variable is written with the terms in order for greatest degree to least degree. So that's what I was just talking about. That would be considered descending order. So let's write that in here. That's from greatest degree to least degree. So that's considered your standard form. That's typically how you're going to organize your answers. The leading coefficient is, when written in standard form, the coefficient of the first term. So the last example that we looked at, the leading coefficient, the whole first term is 6x to the fourth, so the leading coefficient is 6. So let's look at some polynomials and write them in standard form. And then they want you to give the leading coefficient. So for example 1, let's find the degree of each of our terms. So for this term, if you look at the exponent, you can't see it, so it's understood that the x has an exponent of 1, so this has a degree of 1. The next term has an exponent of 5, so there's no need to add anything together. The next term is a constant, and so remember, constants always have a degree of 0. And then the last term has an exponent of 2, so it has a degree of 2. So we're going to write these in terms of highest degree to lowest degree. So and you have to keep the sign of that term with it. So this is the term of the highest degree. It has a sign, and that's not a subtraction sign. We're going to think of that as a negative sign. So that negative has to stay with a 4x to the fifth. So we have a negative 4x to the fifth. Then the next largest number is 2, and then it has a negative in front of it. So the negative x squared is going to come next. Then the next highest number is 1, so the 20x comes next. And there's nothing in front of it, but it's understood to be positive. So we have a plus 20x. And that leaves the last term, which is our constant, of positive 2. So this is now considered in standard form, which is descending order. Look at example 2. Again, the degree of our terms for the first term, y cubed. There's no exponents to add because there's only one base, so that has a degree of 3. The second term, y to the fifth, has an exponent of 5, so it has a degree of 5. And then the last term, the y doesn't have an exponent, so it's understood that it's 1, so it has a degree of 1. So the highest degree term is the y to the fifth, so we're going to put y to the fifth first. The next highest degree is the y cubed, so plus y cubed, because it's understood, there's no sign in front that it's positive. And then finally, the plus 4y. And so now we have our polynomial in standard form. And I think that's it on that page, yeah. Classifying polynomials. Alright, so if a polynomial has a degree of 0, in other words, the whole polynomial has a degree of 0, that means that it must have only a constant in there. So the name of that polynomial has to be constant. So an example of that would be 5 or negative 2. For a polynomial to have a degree of 0, there can't be any other variable raised to an exponent other than like an x to the 0. If the degree of the polynomial, so let's put our examples off to the right here. So an example might be like 5. So if a polynomial has a degree of 1, that might look like a 2x. So the x has a degree of 1, and so that is called linear. Why is it linear? Because the graph of y equals 2x is a line. If it has a degree of 2, so that might look like, a popular one would be x squared plus x minus 2. And so if it's got a degree of 2, then it's called a quadratic. If it has a degree of 3, it might look like this, x cubed minus 8. So that polynomial has a degree of 3. and it is a cubic. If it has a degree of 4, you get the idea. It would start to look like something like this. Oh, I don't know, 3x to the 4th minus x plus 10. And so a degree of 4 is called quartic. And then a degree of 5, we're not going to continue, I think you get the idea with the examples, would be a quintic. And a degree of 6 or more, you're just going to say 6th degree, or 7th degree, etc. If it's to the 15th degree, you say 15th degree polynomial, and so on. So how do we classify a polynomial based upon its terms? So what we just did was classify a polynomial based upon its degree. Based upon its degree, it's called one of these. But based upon the terms, if you would have one term, it is considered, get a different color here, it is considered a monomial. And so that's what we started the lesson off with. Well, let's get a better tail on that. All right, if it's got 2 terms, it's a binomial. Bi meaning 2, nomial meaning terms. 3 terms, it is a trinomial. And 4 or more terms, we just call it a polynomial. All right, last page. So you've got some examples where you're going to classify each polynomial according to its degree and its number of terms. So based upon what we just talked about. So look at example 1. 5x minus 6. So the degree, let's go ahead and find the degree of each term. So the degree of this term, we've got x to the first. That term has a degree of 1. The degree of the second term, it's a constant, so it has a degree of 0. So the polynomial has a degree of 1, which means that it is considered a constant. I'm sorry, not a constant, what am I thinking? A linear. So that's its classification based upon its degree. And based upon its terms, it is a binomial. Example 2, we have 3 terms this time. The first term has a degree of 2. The second term has a degree of 1. And then the last term is a constant, so it has a degree of 0. So the 2 has the highest degree. So its degree is 2. Because it has a degree of 2, it is considered a quadratic. And then the number of terms it has is 3, so it's considered a trinomial. Last problem on this page, example 3. This one has 4 terms, so the first term has a degree of 7. The second term has a degree of 2. The third term has a degree of 1. And then the last term is a constant, so it has a degree of 0. Because 7 is the highest number, that means that our polynomial has a degree of 7. So the degree of 7, it's considered a 7th degree polynomial. And based upon the number of terms, we've got 1, 2, 3, 4 terms. Based upon 4 terms, it is considered just a polynomial. And that does it for today.